I want to go through and I want to talk about how we would go about finding the number of meters that our rockets traveled into the air. We're going to have to do this mathematically. You are going to need one of the Space Exploration Merit Badge pages. On the top here it gives us our equation. Our equation is rocket's altitude equals the distance from the launch pad, or the launch point, times tangent, which is going to be figured out based on the angle of our elevation. So what we did was we got the number of degrees that our rocket went up in the air. We're going to take that number of degrees and we're going to convert it into a tangent. And we're going to use this pink sheet to do that. So I want to go through a couple of examples for how to do that. We'll use some specific examples that I collected from launching my rocket. So this right here should look familiar. This is the first data table inside of your lab report. You'll notice I've collected a number of degrees for each launch. So this right here, launch 1, would be 200 milliliters at 75 psi. And then the next one was 300 and 400 and on down. Alright, so first thing that I need to do is I need to look at my degrees for my first altitude tracker. So in this case I got 30 degrees. I'm going to take that 30 degrees and I'm going to find a tangent for it. Because our rockets, everyone that was doing their launch was 30 meters away from the person that was altitude tracking, my D is going to equal 30. So my altitude equals 30. I replace D with 30 because 30 was the distance away from the launch pad that the altitude tracker was. And then I have to go over here and I have to fill in this tangent. So I go to my first degrees, which is 30, and I look in this chart for my angle degrees and I go all the way down here to 30. And I get 0.5774. And I pull out my calculator. Put a calculator that you can see well here. So again, I'm 30 meters away from the launch pad if I'm an altitude tracker, so I have 30, and I multiply that by the tangent, times, in this case it went 30 meters in the air, so I find 30 on my chart, and I substitute tangent with that number right there, 0.5774. And it gives me 17.32, and I'll just round that to 17.3. So it went 17.3 meters in the air. Alright, so then I come over to my next one, my second altitude tracker. They got 33 degrees. Figure out my calculator. Again, for my equation is altitude equals 30 because I was 30 meters away. That will always stay the same. I will not ever change that. And then I have to substitute tangent. So I got 30 times, I go in my sheet, and I find 33 because I was 33 degrees away. I find 33. 33 is right here. It's 0.6494. 0.6494 equals 19.482. So in this case, I would probably round 19.4 up to 19.5. Anytime you're doing this, keep or round to the nearest tenth. So I'm going to go 19.5. So that altitude tracker got my rocket as going 19.5 meters. Then I go to my third one, 31 degrees. So again, it's 30 times, in my chart I go to 31 degrees, which is 0.6009. 0.6009 equals 18.027. In this case, I'm going to round it just to 18. Alright, now to check my work, I want to average the degrees to begin with. So I'm going to average that all up. Remember, an average is when I take all of the numbers that I have, add them all together, and divide by the number that I added together. So in this case, it would be 30 plus 33 plus 31 divided by 3 because there was 3 units that I added. So 30 plus 33 plus 31 equals 94 divided by 3 equals 31.3. So we got 31.3 degrees is my average. Now I want to double check my average between degrees and meters. So I can actually take degrees and I can say, okay, I got 31 degrees. And I'm going to go on this chart and I know 31 degrees is right here. And I'm going to substitute it. I'm going to figure out the number of meters that degrees would equal. So I've got 30 times 0.6009 equals 18.027 again, so I'll just say it's 18. I'm going to put that right there. So that was my average. As far as when I converted 31.3 degrees into meters. Now I'm going to go down here and I'm going to average out all of my meters. So I've got 17.3 plus 19.5 plus 18 equals 54.8 divided by 3 equals 18.2. So my average meters equals 18.2, and I'll round that to, I could round that to 18.3, I suppose, because the 6 would round that 2 up to a 3, so I could say 18.3. So my average height is 18.3 meters for 200 milliliters of water at 75 psi's. And I want to double check myself. So I go back and I look at that 18 that I put right there in the corner. And that 18 is within 3/10 of the average that I got for this entire average. So that tells me I'm pretty darn close to the average that I got for degrees is pretty darn close to the average that I got for actually converting them. So that's just a way for mathematically for me to check my answer. Alright, let's move on and do launch number 2. And let's kind of check out launch number 2 as an extra example for you when you get ready to start doing your number of meters for your launches. So again, I'm always multiplying by 30 because 30 is the distance away from the launch pad. So 30 times, I've got 33 degrees here. I go into my chart, I find 33. It's 0.6494. 0.6494 equals 19.48, and I'll round 19.48 up to 19.5. next one is 35. So I got 30 again, times, go to my tangent function, try to figure out what tangent is. 35 inside my chart, I go to 35. It's 0.7002. 0.7002 equals 21. My third altitude tracker got 37 degrees. So again, it's 30 times, go to 37 degrees in my chart. 37 degrees is here. 0.7536. 22.6. Alright, so that's average outer degrees. 33 plus 35 plus 37 equals, divided by 3 equals 35. Now let's find the average for meters. 19.5 plus 21 plus 22.6 equals 63.1 divided by 3 equals 21. So my average meters was 21 meters for 300 milliliters at 75 psi. Now we always want to go back and double check our work. So I'm going to double check to make sure that I was correct. So I take 30 times 35 degrees. I got to go to my chart. 0.7002 equals 21. I'm going to put 21 up here in the corner. And my 21 equals the same thing as what I got for averaging my meters. So my check is correct. You are going to need to go about doing this for every single one of your launches. Once I've found out my average meters here, I need to take that information and I need to put it inside of my graph. So I've got my meters. I'm going to take that average number of meters right here. I'm going to put it in my next chart just to make it easier on myself. So 18.3 meters. For my launch number 2, my average was 21 meters. 21 meters. And I'm going to take this information and I'm going to put it inside of my graph. So my graph title is Eggonaut Launch Heights. This right here should be height. And I'm going to create my graph. We started with 200 milliliters of water. My labels on, and I would keep going all the way up to 700 milliliters. here's my height. So this scale may be different on some people's dependent upon the height that their rocket went. So for me, I'm going to say my height of my rocket was started at 18. So I might say I'm going to go by 5 intervals every 2. So I got 5 meters, 10 meters, 15 meters, 20 meters, 5, 30, 35, 40, 45, 50, 55. Alright, so I go back over to this table, and I look and I see that for 75 psi's with 200 milliliters of water, I got 18.3 meters. I need to put a dot on my graph where that location is at. So I go to my 200 milliliters, I go up to where 18.3 is. 18.3 is right about in here. Put a mark. And then I go to my 300 milliliters. I got 21 meters for 300 milliliters. So I go up and I put a mark. Let's do one more so that we can kind of see what's happening with my line graph here. So I've got at 400 milliliters, I've got 36. So I want to find out the number of meters that my rocket went up into the air. So I've got 30 times, so I go 36 degrees, I find it in my chart, it's 0.7265. 21.79, so I'll round that to 21.8. Next one, 30 times 40 degrees, I find it in my chart, is 0.8391. Equals 25.1, I'll just say that's 25. Well, we can round that up to 25.2 because the 7 would round the 1 up to a 2. And then 42 degrees, so it's 30 times, go in my chart, 42 is 0.9004. Equals 27.012, that's just 27. Average them all out, and we're going to skip doing the degrees right now because we're going to try to hurry so that you can see it, get the graph, get its next point put on it. So I got 21.8 plus 25.2 plus 27 divided by 3 equals 24.6 repeating, so we can round that up to 24.7. So my average height in meters for 400 milliliters at 75 psi is 24.7 meters. So I then take that information, go to my chart. So my data table, I want my average meters right here. For 400 milliliters of water, it was 24.7 meters. I then take that information and I I need to put it inside of my graph. 24.7 for 400 milliliters of water. I go up to 24.7, which is darn close to 25. So I'm going to put it just right underneath that 25 line. I'm going to put my mark. And we can see that we are starting to create a nice little line graph. And I can connect these lines. And I could turn them into a colored line, where I could label that colored line as being all of my launches for 75 psi's. And then I would probably create a new line with my 65 psi launches. And that line would be a different color. And as I continue to work through this, I'm going to see a trend in some of this data that I'm collecting. As I go through and I figure out 500 milliliters, 600 milliliters, 700 milliliters, I will see a trend.